Unit 5, Video Lecture 3, Molecular Bonding. A covalent bond is formed by elements sharing electrons. This is different from ionic bonds, where ionic bonds were because the atoms give up or accept electrons. Here, if you notice, these two atoms are overlapping these two electrons. These two electrons are shared between those two atoms. Here in water, we see the overlapped electrons between the hydrogen and the oxygen, and the shared electrons in methane and ammonia. So a covalent bond is formed between two nonmetals. If you recall, our ionic bond was formed between metals. It involves the sharing of electrons, where this is complete gaining or losing. Our melting points are low in covalent compounds. Covalent bonds are weaker than ionic bonds. One way to keep in mind to remember this is that salt, NaCl, an ionic compound, it doesn't melt. You can't melt that on your stove. However, it is possible on your stove at home to melt sugar, a covalent compound. This leads us to believe that covalent compounds are not as strong as ionic compounds. When we talk about ionic compounds, or even just any type of substance held together by a covalent bond, we call it a molecule. And a molecule is a group of two or more atoms bonded covalently. Notice it says atoms, okay, not elements. That's because we can call something like O2, which would be two oxygen atoms bonded together, how oxygen normally exists in our atmosphere. This is still a molecule, even though it's more than one atom. The fact that it's covalently bonded makes it a molecule. Oxygen is just an example of one of our diatomic molecules. Our prefix di means two, atomic means atoms. So this is a molecule made up of two atoms. And these atoms are of the same element. There are 7 diatomic molecules, and I remember it using the mnemonic device, I have no bright or clever friends. And the reason that the I, the H, the N, the BR, the O, the CL, and the F are in red and underlined is that those are the symbols of our nonmetals that exist as diatomic molecules. The I is iodine, H hydrogen, and nitrogen. Br is bromine, oxygen, chlorine, and fluorine. These 7 elements exist as diatomic molecules. If we want to name covalent compounds, just like when we did ionic compounds, the first atom is going to keep its name. So in an ionic compound, the cation kept its name. Here, the first element is going to keep the name. Just like in ionic compounds, the second atom, we're going to use the root and add the suffix IDE. So these two rules are still essentially the same as an ionic compound. So where does the difference come in? It comes in that we use prefixes. And we're going to use prefixes to indicate the number of atoms that are present in a compound. It's important to note that if we don't have, or if we only have one atom of our first element, we're not going to use a prefix. So our common prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. If we think about it, a tri, like a triangle, has 1, 2, 3 sides, so the prefix tri means 3. A pentagon has 5 sides, and so our prefix penta means 5. Our hexagon, 6 sides. Hexa means 6, hepta 7, octa 8, nona 9, deca 10. So let's practice. Our first element. Which element is it? It's nitrogen. There is one of them because there's no number written here, so we have an understood one. Our second element is oxygen. And if you recall, we're going to use the root of this word and add the suffix ide, so oxygen is oxide. How many of them? There are 2, which means that we use the prefix di. So the name for this compound would be nitrogen dioxide. Let's look again. Here we still have nitrogen and oxygen, but notice we have different numbers. So the first element, nitrogen, still keeps its name. However, there are 2 of these nitrogens, so we need to use the prefix di. So this would be dinitrogen. Our second element is oxygen. So we're going to keep the root. And add the suffix ide. The prefix 3 tells us tri, so this is dinitrogen trioxide. If we look at PBr5, the first element is phosphorus. There's only one of them, so we do not need the prefix. Our second element is bromine. So bromine becomes bromide. And there are 5 bromides. The prefix for 5 is penta. So our second compound is phosphorus pentabromide. FBr. Our first element is fluorine. It's the leading one, so we don't need our first prefix. Our second element is bromine. It's going to be bromide again, but in this case, with the 1, our second element needs that prefix mono. So it's fluorine mono bromide. So take a second, pause the video, and try these 4 covalent compounds. Carbon monoxide, carbon dioxide, tetraphosphorus hexoxide, and silicon dioxide. So let's go and let's work the other way. This is actually a little bit easier than when we were doing with ionic compounds, where we needed to balance the charges and make sure that we had the right number of elements with the right charges matching up. Here, the name tells us exactly how many and what is present. So since we're dealing with diboron, that means that it's B2. Hexahydride is H6. Diamines 2, boron is B, hexa is 6, hydride is hydrogen. Carbon tetrafluoride. So because we have carbon, we're going to use a C. No prefix means that we're only going to have one. Tetra is going to mean that we have 4. Fluoride is what we turned in from fluorine. So CF4, 4 fluorines. And then tricarbon monohydride. The prefix tri refers to 3, and carbon. So we have 3 carbons. Nana is 9. Hydride is hydrogen. So C3H9. So take a second, pause the video, and practice these 6 on your own.